I grew up in Connecticut, which was a great experience. I grew up in Somers, which is almost on the Massachusetts border. So went there from grade school through high school. I wasn't really introduced into engineering really until high school, I would say. I always enjoyed math and science, but I also really thought I was going to become a ballerina when I was in middle school. So when I started focusing on what I wanted to do in college, I started thinking about what I liked and what I didn't like, and math and science still really rang true to my skill set and to what I enjoyed doing. That was the first homework assignment that I would do, is math and science homework. So I started to take a look at the engineering programs and enrolled in the Scientific Principles of Technology class, which was a pre-engineering course in high school, which I just loved. I was the only girl, but it was still an awesome experience, and all the boys would say that they're going to cheat off of me on off all my tests. So, so I decided, yep, engineering is the right thing for me to do. And at the time, my parents didn't know where they were going to live. They might get relocated. So I applied to engineering schools up and down the East Coast. But then when it turned out that we were going to stay in Connecticut, I decided that UConn was certainly the most economical and a great opportunity for their engineering program that was rapidly growing and still is now. So yeah, I enrolled into the mechanical engineering program at the University of Connecticut in 2005, and really just loved every moment of it. I had great opportunities. Even though it was a large school, the School of Engineering is small enough that you still can get as much personal time as you want with the professors. So it was really nice. It was still kind of a small school, even though it was within a large university. So it still had all the large university resources, but still a small school, same people in all my classes in that type of situation. So from that, I actually was able to get an internship at Pratt & Whitney, which is in East Hartford, Connecticut. And at Pratt & Whitney, as an intern, I did some vibration analysis, and I was an intern in the component test lab. So we did vibration analysis and used to break things, which is always really fun when you're an engineer. So I did that, and by the time I left that summer, I had an offer to come back the following year after I graduated to work full-time. So that was awesome to start your senior year with already a job offer in hand. So I took the offer and came back in May of 2009 and started in the Applied Mechanics lab as a statics test engineer. In March of 2012, I joined the additive manufacturing group, where they had just started on the cusp of introducing metal additive manufacturing into the Pratt & Whitney technology plans. And whereas before that, Pratt & Whitney had been involved in additive for the past 25 to 30 years in the plastics realm, but now there was becoming aerospace quality metal additive, which was really going to be the next jump for the technology. So I was able to start the technology progression of electron beam melting, which is one of the technologies. It's powder bed technology, and progress it through the technology and manufacturing readiness levels. So that was really an awesome experience, multi-million-dollar activity that I had the responsibility for. I had to give presentations to management. I had to initiate builds in the actual machine, learn a lot about the technical parts of the technology, teach about the technology to other people to be able to substantiate the technology progression, interact with very many different disciplines on a daily basis, which was a good opportunity. Additive manufacturing is a technology that, instead of your conventional methods of creating a part or piece of hardware where you're taking a block of metal and removing material, you're actually adding material layer by layer. So the technology that I work with metal additive, uses a powdered metal and you lay a layer of powder down and use an energy source of either a laser or an electron beam to melt a cross-sectional area. And then another layer of powder is put on top of that, and again, the laser or electron beam will melt the next layer. So it's very small layers, in about 2/1000ths of an inch or around there. So it's very, very small, thousands of layers per part, but what it affords is the ability to make very interesting shapes that you wouldn't necessarily be able to make with conventional technologies. It's actually really great because we use the desktop 3D printers as a learning tool in our engineering environment at Pratt & Whitney. So we're able to use that as a tool to introduce the types of shapes that you can make, to learn about orientation and support structure. There's still design rules in additive manufacturing. You can't just make anything that you can dream up of. There's still always limitations, but it really provides the engineers like a hands-on opportunity to look at the additive manufacturing possibilities. I really love when somebody comes to me and knows a little bit about it but doesn't know all of the possibilities and potential, and you can kind of inspire them and open their eyes. It's really a cool thing to be able to say, "Did you know that you could do this?" And they're just amazed at it. And just seeing how the industry is evolving. The industry is going to continue to evolve over the next 5 to 10 years into something that's much more production ready, quality ready for like an aerospace vibe to it. And when that happens, it'll be really pretty game changing. With additive, it's really interesting there's a good opportunity in that you can do design iterations very quickly. So there's concept to real part is a very quick iteration process. So instead of engineers sitting and designing something and it taking 9 months before they actually have it in their hands, they can go print it on a desktop printer and have it in their hands in 9 hours. And that's really, really cool to be able to sit there and you can sit at design reviews and say, okay, what makes sense about this part? What doesn't make sense about it? And you can, assemble multiple parts together and think about, okay, are the people that are assembling this going to have difficulty doing this? Let's think about all these things up front so that you can better, more efficiently design your parts. So that's a really cool thing that you can do. I think it wasn't what I made, it's what I accomplished. So I was able to take a technology from a feasibility standpoint and make it feasible for production. So being able to bring something that, bring a technology that has a lot of naysayers and people that don't believe that it's going anywhere. And then there's also people that thought it was the next best thing and were putting too much hype into it and too much it was going to overtake conventional machining and overtake casting, which isn't true. It's a complementary technology. So to take something that had a lot of unknowns and take out a lot of the variation and take out a lot of the mystified, things about it and make it, kind of more mainstream and more, okay, we know how to deal with this. There's benefits and there's drawbacks, and kind of create a more solidified design space. I think that people and women, especially in engineering, you still have to find what your passion is, and your passion might be to change the world psychologically or culturally, but your definition of changing the world might also be technically, and that's an awesome situation to be in. So I feel like I'm technically changing the world, and to be able to use additive manufacturing and implement that into aerospace, we're going to see lower weight engines, which is going to be more affordable. It's going to be we're going to expand in the nation, just be able to really do things and create things that we weren't able to do before. There's so many opportunities in additive manufacturing. If you want to be super technical, you can. If you want to go, make 3D printed prosthetic hands for children, it's like, the opportunities are really pretty endless in the industry. Again, it's really a personal passion. So when I had opportunities, even when I was a freshman in high school, and I remember in the summer I was picking out my classes and the electives that we got to take. And the elective that I chose was computer programming, and it was a basic class. And my dad was like, I think that you'd really like that class. And, my mom was like, yeah, you'd totally like that class. I got into it, and I was the only girl, and I was also the only freshman. So I just had all these upperclassmen male students and peers. And, I think I was super intimidated for the first 2 weeks or so. But after that, I was like, oh, I can do all of this stuff just as good as they can, and I'm getting probably better grades because I'm not goofing off like they are. So I think that was kind of like my initial introduction into, oh, I can do this just as well as they can. And I kind of progressed into that. And I think by the time I got into college, I didn't even notice it. I didn't notice that there was so much more, or that there was this cultural stigma around a woman being in a technical field. Yes, there was probably only 10% to 15% female in my econ classes, but I wasn't affected by it culturally. I wasn't affected by it mentally. I found it to be a great opportunity because when there's few of you, you get to be recognized and you get to be, sought out. So it's been, I think, a great opportunity. When I continued into Pratt and Whitney, and when I continued into my job, again, I had I think a lot of confidence that was built throughout high school and throughout college that I didn't really worry about it. And when you don't worry about it, things seem to kind of fall where they may. Certainly that provides a level of comfort to know that, they really paved the way for us to be able to be in these fields without having all of these social pressures against it. And that's really comforting to know that there are still many, although there's still less females in the breakdown of male to female, I still think that there's a good sense of community in, helping females, other females helping females continue to succeed. It can start as early as you want, but it's never too late. So if you're late in high school and you're like, I want to do engineering, then go figure out how to get that done. There's always so many resources to help you succeed. If you have a passion for engineering, then join a FIRST Robotics team, join any clubs that are doing. In college, we did Formula SAE, where we created, cars, and I think there's lots of opportunities there. For additive manufacturing, go buy a 3D printer. They're at this point so inexpensive to make yourself. You can create one yourself and with a kit and be making doodads for your house and, for your room, and that's really fun. I think that it's important to focus on school and still focus on, making sure that you apply yourself the best way that you can. No, it's not easy. It's not something that is necessarily going to come super naturally. But once you start it, it can be really fun and rewarding. I think that the reason, or some of the reason, that women are still really great people to go into engineering, we are great multitaskers. I think there's probably studies that show that women can manage a lot of things at a lot of times. And that's obviously a good thing when you're trying to manage a program with so many inputs and outputs. I think that women can be very passionate about their relationships, but also about the things that the actions and milestones that they have. So bringing a level of passion and empathy to the people around you, as well as the activities that you're doing, can really enrich the work atmosphere, can enrich the programs, and can bring thought processes that are kind of outside the box. So I think all of those things really add to why it's not a why should women go into engineering, but it's why shouldn't women. There's not really any reason. The best piece of advice that I would say I can give is that you can do anything you put your mind to. There are no limitations when it comes to gender. There are no reasons that you can't do what you think that you can achieve. So whether that is going into engineering, whether that is going into nursing or pharmaceutical or chemistry or math or anything, I think that if you have the drive to do it and you have the passion to do it, there are resources out there for anyone to achieve what you want to achieve. When I'm looking for employees, I really want to focus on what what do they think that their strengths are. So somebody that can articulate what their strengths are is really important, and understand that their strengths, their strengths and weaknesses are okay, whatever those strengths and weaknesses may be. So for somebody that is somewhat more of an introvert and they enjoy, task-related items, that's an awesome opportunity for someone to be placed in that type of work experience. If someone really loves presenting and has a passion for being in front of people, then there are great opportunities for them to be placed in jobs like that. Your strengths and weaknesses are not good and bad. They make up who you are, and there is a job for you. You just have to find out what it is. The only thing that I would say that I have found interesting, or like my own personal experience, is that many females seem to not want to go into the STEM field because they think it's nerdy or they think it's not cool. But from my own personal experience, you can do engineering and you can also be a fashionista. You can do engineering and also, take dance classes. You can do engineering and also enjoy cake decorating, whatever it is, and all of those things, it makes up who you are. It doesn't mean that engineering is nerdy or mathematics is nerdy. I think that embrace the nerd, but also do the things that you want to do.